Today we are going to start a new unit from physical chemistry and inorganic chemistry papers. The paper unit title is Organometallic Compounds. This topic is in physical and inorganic chemistry paper. Okay. Can anybody tell me my voice is clear to all you? Hello?
Yes, sir.
Hello? येतोय का आवाज क्लिअर?
हो सर.
Okay. So we are starting the organometallic compounds. This is unit from physical and inorganic chemistry paper. Now, what are the organometallic compounds and what is its importance? Firstly, we will see what is the importance of organometallic compound, its history, etc. In 1827, firstly, Zeeth salt was prepared, and it is the first platinum olefin complex in which this organic olefin group C2H4 group was the ligand. So this first organometallic compound metal with some organic group as a ligand is prepared firstly in 1827. In 1863, Friedel and Crafts prepared some organochlorosilane. Okay. Then in 1890, Yelmond discovered nickel carbonyl. We have studied in metal carbonyl. This is nickel tetracarbonyl. Then this is the very well known reaction, Grignard reaction. You know the Grignard reagent? These are the organomagnesium compounds. And the importance of this Grignard reagent is that almost all classes of organic compound, hydrocarbons, etc., can be able to prepare by using this Grignard reaction. So this Grignard reaction is found in 1899. Then in 1900 AD, the Savitar work on hydrogenation of organic compounds. Then in 1912, Grignard and Grignard reagent is discovered, and from for that he has awarded the Nobel Prize for the discovery of Grignard reagent. In 1930, Henry Gilman works on lithium cuprates. These are lithium cuprates, copper, lithium, and this R is the organic group. Okay. Then ferrocene in 1951, ferrocene was discovered. This is the ferrocene. Then the Nobel Prize was given for Ziegler-Natta catalyst. This is Ziegler-Natta catalyst. This is also organometallic compound. Then Heck reaction, etc., etc. So these are the history of these organometallic compounds. Also, this is a Nobel Prize for silver compounds, sandwich compounds, Wilkinson. Also, there is Wilkinson catalyst is also there. Then in 2005, Nobel Prize for alkene metathesis. In 2010, there is Nobel Prize for palladium catalyzed cross coupling in organic synthesis. So this is the history of organometallic compound. From previous, we may see that there is one Nobel Prize for Grignard reagent, second Nobel Prize for Ziegler-Natta catalyst, third Nobel Prize for the sandwich compound, fourth Nobel Prize for alkene metathesis, and the fifth Nobel Prize is for this palladium catalyzed cross coupling reactions. Means up till now, five Nobel Prizes were awarded for the research work in organometallic chemistry only. So you may see what is the importance of these organometallic compounds. Okay. Now, why these are so important? Why these organometallic compounds are so important in the chemistry? Before seeing that, we will see its definition. Organometallic compounds are the materials which possess direct carbon metal bond. In organometallic compound, there is direct metal and carbon bond. That bond may be more or less polar, but they contain the Polar carbon metal bond compounds are called as organometallic compounds. In addition to these, some semi-metals like boron, silicon, arsenic, selenium, compounds of these elements with the organic group having direct this element and carbon bond are also termed as organometallic compounds. And the organometallic chemistry is the study of these organometallic compounds. So you might have understood the definition. Organometallic compounds are the compounds in which there should be the direct bond between metal and carbon. There should be direct bond between metal and carbon. For example, if you take sodium carbonate, that is the inorganic one. So for example, say sodium ethoxide or sodium acetate. In sodium acetate also there is one organic group and one metal, but there is no bond between metal and carbon. There is bond between metal and oxygen in sodium acetate. So sodium acetate is not a organometallic compound. Okay. So in a organometallic compound, there must be direct metal carbon bond, and definitely this metal carbon bond is polar, more polar or less polar, but it is the polar bond because metals are electropositive and carbon is electronegative. So the metal bears positive charge and carbon bears negative charge in the organometallic compounds. Okay. Now, up till now, we have seen 5 Nobel Prizes were awarded for the work in the field of organometallic chemistry. Why these compounds are much more important in the chemistry field of chemistry, mostly in the field of synthetic organic chemistry and catalysis. Okay. You might have studied the Grignard reagents in 11th, 12th, wherever. From these Grignard reagents, we are able to synthesize alkanes, alkenes, alkynes, alcohols, aldehydes, ketones, acids, amines, amides. Almost all classes of organic compounds can be synthesized by using the Grignard reagent. Similarly, now we are going to study organolithium compounds, organozinc compound, etc., etc. So the almost all organic classes of organic compounds can be prepared by using these Grignard reagents. These organometallic compounds. But while seeing the organic reagents, for example, say acid chloride, you might have know the COCl3, CS3COCl. That CS3COCl, in that the chloride leaves and the positive charge is there on the alkyl group, on the organic group. The group which one leaves from the organic group, that is the negative part. Okay. म्हणजेच काय आपल्याला बाकीच्या रिएजंट्स मधून हा कार्बो कॅटायन मिळतो. अल्किल ग्रुप वरती ऑलवेज पॉझिटिव्ह चार्ज येतो. But in case of organometallic compounds, metal is more electropositive than carbon. So we get carbanian ion. We get carbanian ion, that the alkyl group which resides when metal leaves, that alkyl group bears negative charge. That bears negative charge. The such ions are not obtained by any other reactions without organometallic compounds. कुठल्याही ऑर्गॅनिक कंपाऊंड घ्या, त्याच्यावरती तुम्हाला कार्बन वरती निगेटिव्ह चार्ज येत नाही. एखादा ग्रुप जर लिव्ह झाला, जर नायट्रो कंपाऊंड घेतला, नायट्रो ग्रुप लिव्ह झाला, पॉझिटिव्ह चार्ज येईल तिथं. किंवा दुसरा कुठलाही घ्या, तर कार्बन जो अल्किल रेसिड्यू राहतो, ऑर्गॅनिक रेसिड्यू राहतो, त्या रेसिड्यू वरती पॉझिटिव्ह चार्ज येईल. बट these organometallic compounds provides alkyl groups with negative charge, and because of this they have very much importance in the field of organic synthesis. They have very much importance in the field of organic synthesis. So Grignard reagents, organolithium compounds, etc., whatever the compounds we have seen, organometallic compounds, they are act as a reagents for the synthesis of organic compound, various classes of organic compounds. So these are the starting materials or the reactors for synthesis. Then these are the catalysts. These organometallic compounds are mostly catalyst. They catalyze some other reactions also. For example, that trimethyl hydride. It is the catalyst for this is the catalyst for polymerization reaction, free radical polymerization reaction, etc. We have seen this is the Ziegler-Natta catalyst. For this catalyst, development of this catalyst, they have got Nobel Prize in 1963. It is an organometallic compound, and this Ziegler-Natta catalyst is used to carry out various transformations in the organic chemistry. And one more peculiarity of these catalysts are they are selective. They are selective. They are not so much versatile. समजा आपल्याला पर्टिक्युलर एकाच ग्रुपवर रिएक्शन करायचे, दोन ग्रुप आहेत, दोन ऍक्टिव्ह सेंटर आहेत एखाद्या मॉलिक्युल मध्ये. If one target molecule contains two active sites, but we have to carry out reaction at one particular site only, then such type of organometallic catalysts are useful. So the Ziegler-Natta catalyst we have seen, for that they have got the Nobel Prize. Another one we may say the Wilkinson catalyst. This Wilkinson catalyst is also there. Some other many more catalysts are there which are the organometallic compounds. Okay, so the organometallic compounds are reagents for organic synthesis. These are catalysts for various organic transformations. Because of these, they have very much importance in the field of organic synthesis or in the field of chemistry. That's why up till now 5 Nobel Prizes were awarded in the field of this organometallic chemistries. Okay. So we have seen the definition that there must be metal carbon, direct metal carbon bond, and obviously this bond is more or less polar bond. Now we will see the classification of these organometallic compounds, how these organometallic compounds are classified. These organometallic compounds are classified depending upon the nature of metal carbon bond. That the metal carbon bond may be ionic bond, that bond may be covalent bond. Okay. If the bond is ionic, then this is called as ionic organometallic compounds. If the bond between metal and carbon is covalent, these are called as covalent organometallic compound. Obviously, just we have said that bond between metal and carbon is polar, so that is not 100% covalent. Okay, that bond between metal and carbon is not 100% covalent, but if it has more than 50% covalent character, we say it is covalent. So depending on that, these are classified as ionic organometallic compounds, covalent organometallic compounds, electron deficient organometallic compounds, and transition metal organometallic compounds. So the organometallic compounds are classified into four classes. One, ionic organometallic compounds, covalent organometallic compounds, electron deficient organometallic compounds, and transition metal organometallic compounds. Now we will see one by one what are these. Ionic organometallic compounds, as its name indicates, there is ionic bond between metal and carbon. There is ionic bond between metal and carbon. We have seen bond between metal and carbon means this carbon in this organic group, this carbon is bearing negative charge. This carbon is bearing negative charge. Okay. When we say the sodium acetate, CH3COO Na, there is also ionic bond, but the negative charge is not on carbon. In case of that, negative charge is on oxygen. That's why these are not organometallic compound, but these are the organometallic compounds because there is negative charge on this carbon. So the organometallic compounds having ionic bond are called as ionic organometallic compounds, or simply we may say more than 50% ionic character, then these are called as ionic organometallic compounds. Now we know the properties of ionic compounds. Salts, these salts are insoluble in organic solvent or non-polar solvents. Similarly, these ionic organometallic compounds are insoluble in non-polar solvents like benzene, ether, etc. Means these are soluble in polar solvents like water. Water is a polar solvent. So these ionic organometallic compounds are soluble in non-polar solvents, polar solvents, and insoluble in non-polar solvents. They exhibit properties of ionic compounds. All the properties of ionic compounds are exhibited by these ionic organometallic compounds. They are highly reactive. Ionic organometallic compounds are highly reactive, and their reactivity depends upon the stability of anion. Their reactivity depends upon the stability of anion. The compound which contain unstable anion is found to be extremely reactive. हा जो anion part आहे, anion part is the organic part. This anion part is the organic part. This one C4H9 negative. We may say this one, and sodium positive, or C6H5 negative and sodium positive. So this is the ionic part, anionic part. If this anionic part is stable, if this anionic part is stable, then it will remain close to this sodium. जर हा स्टेबल असेल तर हा सोडियम सोबत राहील, सॅटिस्फाईड असेल तर हा सोडियम सोबतच राहील. मग त्याची रिॲक्टिव्हिटी काय असेल, कमी असेल. ची रिॲक्टिव्हिटी जास्त असेल कधी हा ताबडतोब ह्याच्यापासून निघून जाईल. ओके. मग जर हा अनस्टेबल असेल, then it is highly reactive. Unstable, then it is highly reactive. Now this is C6H5 negative. बेन्झीन रिंग वरती निगेटिव्ह चार्ज आहे हा C6H5 निगेटिव्ह म्हणजे. तर बेन्झीन रिंग वरती रेझोनन्स मुळे हा निगेटिव्ह चार्ज स्टॅबिलाइज होईल. बिकॉज ऑफ रेझोनन्स देर इज नो प्रोव्हिजन फॉर बोर्ड अँड चॉक, so that I am unable to show you the resonance, etc. But this is a stable one because this negative charge is delocalized over these 6 carbons in this, because of this is aromatic, because this is the aromatic compound. Okay, so this is not so reactive as this one C4H9. It is butane. C4H10 is a butane. Okay, one hydrogen is removed, H plus is removed, so you get negative charge, and that negative charge is concentrated on one carbon only. There is no pi bond in this compound. C4H9 butane मध्ये pi bond नाहीये. That's why हा negative charge जो आहे तो एकाच कार्बन वरती कॉन्सन्ट्रेट होईल आणि तो लवकरात लवकर न्यूट्रलाइज होण्याचा प्रयत्न करेल. Means that the carbanion, that anion is unstable, so these are the extremely reactive. So the ionic organometallic compounds are more reactive than any other, we may say. Then the covalent organometallic compounds, some lead, diethyl lead, dimethyl cadmium, dicyclopentadienyl, zinc, trialkyl aluminium. These are the covalent organometallic compounds because there is the covalent bond between metal and carbon. There is covalent bond, or more than 50% covalent character in the bond between metal and carbon. Okay, so that is called uh, covalent organometallic compounds. So these covalent organometallic compounds exhibit properties of covalent compounds. Means covalent compounds are soluble in organic solvents and these are insoluble in water. Now, which compounds can form ionic organometallic compounds and which forms covalent organometallic compounds? In previous example, we have seen that the examples of sodium, lithium, magnesium, potassium, etc. First and second group metals. These are the highly electropositive. First and second group metals, alkali and alkaline earth metals, are the highly positive, electropositive. So they form the uh, ionic organometallic compounds because there is much more difference in electronegativity of these metals and carbon. Okay, you might have seen the molecular scale, different percentage ionic character of a bond. That the bond may be ionic or may be covalent. That is determined by the difference in electronegativity of two combining atoms. Okay, so the electronegativity difference between metal and carbon determines the polarity of carbon metal bond. These are polar bonds, but they have more than less than 50% ionic character. So these are called as covalent organometallic compounds. These are quite less reactive than the ionic organometallic compounds. Okay. Now the third class is the electron deficient organometallic compounds. What are these electron deficient? What are the electron deficient compounds and what are the electron rich compounds? When we say the compound is electron deficient, they must be uh, they must have shortage of electrons. They do not complete their octet. Such compounds are called as electron deficient compounds. For example, compounds of beryllium, we say BCl3 or BH3, BE, okay, boron, BF3 or BCl3. So what is the atomic number of boron? It is 5. So electronic configuration is 1s2, 2s2, 2p1. In their outermost cell, second cell, there are 3 electrons. And it is combining with other 3 atoms or it is forming 3 bonds. Means 3 electrons are shared. So total electrons in the outermost cell of boron in the that compound, we may say BF3 or whatever may be, are 6 electrons, not 8 electrons. There are 6 electrons, and one orbital is empty. So such compounds are called as electron deficient compounds. Such compounds are called as electron deficient compounds. They are have lack of electrons to complete the octet, but still they are stable. Compounds of lithium, compounds of magnesium, aluminum, etc. They are the they form electron deficient compounds. Okay. Now we have seen the AlCl3, aluminum chloride. Aluminum chloride is a electron deficient compound because the octet of aluminum is not completed. Now, if in place of chlorine there is some organic group, for example, AlCH3 thrice, AlCl3 thrice, CH3 thrice, CH3 is the organic group. Then it is called as organometallic compound because there is bond between aluminum and carbon. Okay. Now, what type of organometallic compound? Octet of aluminum is not completed. So this is the electron deficient organometallic compound. Such compounds, organometallic compounds of lithium, beryllium, magnesium, aluminium, etc., are called as electron deficient organometallic compounds. They exist in polymeric form. They exist in polymeric form. We say you might have studied the compounds of boron in BSc first year. Boron B2H6, two hydrogens are acting as bridge between two borons. They have the particular type of bond that we call it as a two electron three center banana bond. Okay. So similarly, this is a beryllium CH3 twice n times Al2R6, Mg ethyl twice. These are the electron deficient organometallic compounds. Okay. Now, one more typical character of these electron deficient organometallic compound is that the bond between metal and carbon is not explained by simple concept two electron two center bond. The bond may be ionic, may be covalent. We may say there are two electrons which are under the influence of two atoms, two nucleus. That is called normal two electron two center bond. But in case of these electron deficient compounds, we are not able to explain this bond by a simple two electron two center bond. Okay, so these are the electron deficient organometallic compound. One example we are going to see, that is the aluminium alkyls. Okay. Then the transition metal organometallic compound. See here again, the transition metal has one more property to form the organometallic compounds with some organic compounds which have delocalized pi electrons, which have delocalized pi electron. In previous example, there was the sigma bond. There was the sigma bond. Okay, but transition metals can form pi bond also. So the transition metal bonded to unsaturated organic compounds. These are called transition metal organometallic compound. There is the interaction between p orbitals of organic ligands and suitable p or d orbital of metal. ट्रान्झिशन मेटल ऑर्गॅनोमेटॅलिक कंपाऊंड्स मध्ये काय असते, ऑर्गॅनिक ग्रुपचं पी ऑर्बिटल, प्युअर पी ऑर्बिटल. Okay, in previous cases, in covalent or the electron deficient, hybrid orbital of organic group, hybrid orbital of carbon is interacting with the metal. But in transition metal organometallic compounds, pure p orbital, we call it as pi orbital of carbon is interacting with the p or d orbital of metal, and their structures are like sandwich. So these are called as sandwich compounds also. For example, C6H6 twice, this benzene twice Cr. There is one benzene ring below, another benzene ring above, and the chromium metal, chromium atom is in between these two rings, and there is the bonding between pi electron cloud of one benzene ring and another benzene ring. पाय इलेक्ट्रॉन क्लाउड सोबत बॉन्ड असतो. दॅट इज नॉट पर्टिक्युलर वन कार्बन. 6 कार्बन पैकी कोणत्याही एका कार्बन सोबत बॉन्ड नसतो. दॅट बॉन्ड इज नॉट along with particular one carbon. That bond is delocalizing over 6 carbons. Okay, so such compounds are called as sandwich compounds or transition metal organometallic compounds. Another example is this cyclopentadienyl. This is cyclopentadienyl ion and the iron. This is aromatic. This is also aromatic. We have seen their examples also. These are the examples of sandwich compounds. These are the examples of transition metal organometallic compounds. Such compounds are formed by the transition metals only. Other alkali metals, alkaline earth metals or semi metals do not form such type of sandwich compounds. Sometimes these are called as scene metallocenes. Sometimes these are called as metallocenes, ferrocenes. Okay, so these are the organometallic, transition metal organometallic compounds, and one Nobel Prize is awarded for these metallocenes or ferrocenes. Okay. So these are the classification of organometallic compounds. These organometallic compounds are classified into four classes. We have seen ionic organometallic compounds having ionic bond. Their properties are similar to ionic compounds. They are soluble in polar solvents like water, insoluble in non-polar solvents. These are highly reactive. Their reactivity depends upon the stability of anion. Okay. And such ionic organometallic compounds were formed by the alkali or alkaline earth metals. Then we have seen the covalent organometallic compounds. These have properties like covalent compounds. They are soluble in non-polar solvents. They are insoluble in polar solvents. Some transition metals or some higher metals can form such covalent organometallic compounds. They are somewhat less reactive than the ionic organometallic compounds. We have seen the electron deficient organometallic compounds. The electron deficient organometallic compounds are formed by some elements like boron, beryllium, lithium, magnesium, aluminium, etc. In such compounds, the octet of metal is not completed. That's why these are called as electron deficient compounds. They exist in polymeric form. The their bonds between metal and carbon is not a normal two center two electron bond. Some alkyl groups are acting as bridge between two metal atoms. Such organometallic compounds are the electron deficient organometallic compounds. Okay, we have seen transition metal organometallic compounds. Transition metal has peculiar characteristic to form the to interact with the pi electron cloud, or we may say the p orbital of carbon. There is no sigma bond, there is only pi bond. Okay, so such are called as the metal is trapped between two organic groups like a sandwich. So these are called as sandwich compounds. These are called as metallocenes. One Nobel Prize is awarded for this. Okay, this is regarding the classification. Now, this is the periodic table. Ionic organometallic compounds are formed by these first group elements: sodium, potassium, rubidium, cesium, francium, like this. This can form ionic organometallic compounds. This lithium, beryllium, magnesium, boron, aluminium can form covalent multi-center bonds, means the electron deficient organometallic compound. Covalent bond, but not two center, multi-center bonds. म्हणजे दोन इलेक्ट्रॉन्स तीन ऍटम वरती डिस्ट्रीब्यूट होतील. In normal bond, two electrons were distributed over two atoms, covalent bond, simple covalent bond we say. But they are able to form multi-center bonds. So these shown by the dark one are forming electron deficient organometallic compounds. Okay. First group is forming ionic organometallic compound. These 1, 2, 3, 4, 5 elements only are forming electron deficient organometallic compounds. These are the transition elements from group 3 to 11. These are the transition elements. They are forming transition metal organometallic compounds, metallocenes. These are forming metallocenes. Then these are the metals again. These are forming the simple covalent organometallic compounds. These are forming covalent organometallic compounds: zinc, gallium, selenium, this arsenic, selenium, this phosphorus, silicon. These are the metalloids. Silicon. This line is a of metalloids line. This tin, etc. Lead. These are forming the covalent organometallic compounds. So this is the distribution of metals. Which metals can form ionic organometallic compounds, which can form electron deficient, and which can form covalent organometallic compounds, and which can form the transition metal organometallic compounds. Okay. Now we will see the nomenclature of organometallic compounds. How the names are given for the organometallic compounds. The simple alkyl or aryl organometallic compounds like this CH3Li. This is the simple one. C2H5 twice zinc. This is the simple one. C2H5 MgBr. These are simple. So the simple alkyl or aryl organometallic compounds, then the name of metal are named by writing the name of the metal after the name of organic compounds. Metal is written after the name of organic group. For example, this is the methyl and then lithium. So it is written as methyl lithium. This is the ethyl twice. So it is diethyl zinc. It is ethyl magnesium bromide. So it is ethyl magnesium bromide. This is phenyl magnesium chloride. So simple, the name of organic group is written first, followed by the name of metal in case of simple aryl or aryl organometallic compounds. अल्किल ग्रुप असेल किंवा अरिल ग्रुप्स असेल. फॉर एक्झाम्पल हा C6H5 म्हणजे हा अरिल ग्रुप आणि हा अल्किल ग्रुप. So while naming such organometallic compounds, the name of organic group is written first, followed by the name of metal. Okay. Then nomenclature of carbonyl compounds. We have seen while seeing the metal carbonyls. Nomenclature of metal carbonyls in last chapter. The carbonyl is written first, followed by the name of metal. Okay. So the carbonyl compounds containing CO as ligand are called as metal carbonyls. We know that. We have studied this topic. Okay. Now, if the metal has zero oxidation state, it may not be mentioned. Okay. In metal carbonyls, the metal may be in zero oxidation state or lowest possible oxidation state. मेटल कार्बोनिल मध्ये मेटल हा झिरो ऑक्सिडेशन स्टेट मध्ये असतो किंवा लोवेस्ट पॉसिबल ऑक्सिडेशन स्टेट मध्ये असतो. जर झिरो असेल तर ऑक्सिडेशन स्टेट मेन्शन करायची गरज नाही. फॉर एक्झाम्पल दिस इज टेट्रा कार्बोनिल निकेल. There are four carbonyl ligands and nickel. So that's why tetracarbonyl nickel. Nickel is in zero oxidation state. There are 10 carbonyls in this one. So decacarbonyl dimanganese. Two manganese are there. So it is dimanganese. This is nanocarbonyl diiron. Now, if there are bridging carbonyls, polynuclear metal carbonyls, in which there are the some carbonyls are acting as ether. Then, then before writing the name of such carbonyls, suffix mu, this Greek letter mu is written first. For example, this is CO3. This C small o is for cobalt, okay, and both C and O capital is for carbon monoxide. CO thrice CO, CO twice CO. This is there is some typing mistake. This O is small o, okay, cobalt. Then CO3 thrice means in this formula, what we may say, these three carbonyls are terminal. These three carbonyls are terminal. These two carbonyls are acting as bridge. Okay, so we may say di mu carbonyl means two carbonyls are acting as bridge. Di mu carbonyl bis. There are two groups of tricarbonyl cobalt. Okay, so because of this di mu carbonyl bis tricarbonyl cobalt. See here also tricarbonyl, three carbonyls are acting as bridge. So tri mu carbonyl bis tricarbonyl iron. So likewise, the names for these metal carbonyls is given. Now we have seen nomenclature of pi bonded organic compounds. So if there are some ligands which are capable to form pi bond as well as sigma bond. For example, cyclopentadienyl. This is cyclopentadienyl C5H5. It is capable to form pi bond. It has pi electron cloud, and it is capable to form sigma bond also. Okay, पाय बॉन्ड सुद्धा फॉर्म करू शकतो आणि सिग्मा बॉन्ड सुद्धा फॉर्म करू शकतो. मग त्यानं पाय बॉन्ड फॉर्म केला का सिग्मा बॉन्ड फॉर्म केला हे आपल्याला नेम मध्ये मेन्शन करावं लागेल. सो इन दिस cyclopentadienyl lithium there is formation of sigma bond, so we may write sigma C5H5, and in this metallocene C5H5 twice Fe there is pi bond, so we write pi C5H5. Okay. Similarly, alkyl group is referred as sigma allyl or pi allyl. Sigma किंवा pi. Now, for unsaturated compounds or unsaturated groups, prefix neta is given. This is called as neta. Okay. And above this, at the superscript, number of carbon atoms are given. त्याच्या suffix डोक्यावरती number of carbon atoms. For example, this is C5H5 twice Fe. C5H5 twice, it is cyclopentadienyl. It is unsaturated, so we have written neta, and that pi bond is delocalized over 5 carbons. That pi bond is delocalized over 5 carbons, so we have written 5 here. So we have written 5. Similarly, in this one there is benzene. This is delocalized over 6 carbons, so we have written 6. This C3H5, the pi bond is delocalized over 3 carbons, so we have written 3. So likewise, this is regarding the nomenclature of organometallic compounds. Now, afterward, we have to see organolithium compounds, organoaluminium compounds, organotitanium compounds, and organotin compounds, that we will see later on in our next lecture. Okay, so I think everyone has received clear voice, audio, and video presentation.
Yes, sir, it's clear.
Any problem to someone? No any problem ना? कोणाला
No, sir.
अडचण आली का?
नाही.
आवाज काही
हो,
प्रॉब्लेम
sir.
नाही.